Hey guys, today we're going to talk about rational numbers. So I recreated this diagram that we made at the beginning of the year just to remind you that natural numbers, which is what you learned, when you were smaller, are 1, 2, 3, 4, 5, 6, and so on and so on. Whole numbers include the number 0. So 0, 1, 2, 3, so on and so on. And then integers is the next circle. And so this is the first place that you start to see negative numbers. And then rational are the numbers right here, okay? And these numbers can be written as a fraction, as a over b, where b does not equal 0. So rational numbers are fractions. One way to say it is that they are all these. They're natural numbers, whole numbers, integers. All of these are rational numbers. But yet we go a little further and say that, okay, now we can include fractions. If it can be written as a fraction where b does not equal 0, then it's a rational number. So anytime you see that fraction as a number there, it's a rational number. Now, over here on the right, we have what we call irrational numbers. Those are numbers that can't be written as a fraction, a over b, where b does not equal 0. So you say, well, I get it. This is pi. We know that pi is the most famous irrational number. It goes on forever. The square root of 2 is the same way. The reason that the square root of 2 is not a rational number is because it's not a perfect square. So that would make it irrational. Where the square root of 16 over here, we know that the square root of 16 equals 4, so it's rational. So one of the ways that we say this is that rational numbers have terminating, so ending, so terminating decimals. We can say fractions, perfect squares, well, let's fix that. Let's say that it's actually the square root of a perfect square. So it's the square root of a perfect square. Or cube root, or fourth root, whichever one. But square root would be square root of a perfect square. So those would all be rational numbers. So then you say, well, Miss Rose, this square root of 3 over 6 is a fraction. Well, the problem here is that we know that the square root of 3 is not a perfect square. So the square root of 3 is an irrational number. So that leaves us really an irrational number divided by a rational number, which is irrational. Okay? So that's why, because the square root of 3 is irrational, and this is rational, so this divided by this is a irrational number. So that's why it's there. So let's look at some examples here. So let's say you have 1.4. Would that be rational? Yes, because this is actually 1 4/10, which we can also reduce to 1 2/5. And then 3/7. Now, if you kind of cheat there and type this in your calculator, sometimes the sevenths, I should say, they have more digits that repeat than what your calculator can hold. So you'd think that it doesn't repeat, but it actually does. It is a fraction, so this would be rational. And that would be rational too. Now then, what about the square root of 20? Well, it's divisible by 2, so a lot of people think that it is. 20 is not a perfect square, so therefore this would not be a rational number. It would be an irrational number. The square root of 8 over the square root of maybe 20. Well, I'm not sure, because there's this thing that can happen when you have square roots. So if I simplify this, I could say check it to make sure, is there a hidden perfect square in here? So this could be the square root of 2 divided by the square root of 4, or times the square root of 4, divided by the square root of 4 times the square root of 5. Now, if you'll notice here, you have the square root of 4 over the square root of 4, which is the square root of 2 over the square root of 5, And so therefore that would be irrational because both of these are irrational. One that they like to give you is if you have 3 pi over 6, this really means 3 over 6 times pi. Well, there again we have a rational number times an irrational number, and so this is going to be irrational. Well, then on top of that, they'll give you one that says 2 pi over 3 pi and ask you if that is rational or irrational. Well, here we have to remember that pi over pi is the same thing, and so that is 1, and so really you're left with 2/3. And we know that 2/3 is rational. Some others that I've seen are ones like this one. Maybe not 55. Maybe that won't work. Hold on a second. Let me see. It's not quite the example that I wanted. Okay, so I'm asking myself, are there some perfect squares in here? Well, yes, the square root of 4 times the square root of 11. Well, then this would be the square root of 9 times the square root of 11. Okay? Well, we see here that the square root of 11 cancels out, and you're left with the square root of 4 over the square root of 9. Well, this looks very similar to the one we just had with the square root of 2 over the square root of 5. Both of those were irrational. However, the square root of 4 we know is 2, and the square root of 9 is 3. So we know that this is a rational number. So this is a very complex, hidden rational number. Okay? Now, when we have an irrational number, because they go on forever, we have to estimate those. So if you think about your perfect squares that we talked about, if you look at the square root of 5, you have around that the square root of 4. Then you would have the square root of 5, the square root of 6, the square root of 7, the square root of 8, and the square root of 9. So we know that the square root of 4 is 2, and the square root of 9 is 3. So in the middle right here would be 2.5. So if we wanted to estimate that, we could say that this would be maybe 2.25. And this is in the middle, because that's in the middle of 2 and 250 is 225. And then here would be 275 or $2.75, 2.75, however you want to say that. So if I wanted to estimate this, I would usually do 2.2 or 2.3. Now, knowing that is beneficial, let's say that you have the square root of 5 to the third. Well, one way to do it is say 2.3 times 2.3 times 2.3. And again, because this is irrational, I'm having to estimate it. So that's one way. Another way, this could take a while, this one right here, because I'm having to multiply a decimal 3 times. The other way to think about it is the square root of 5 times the square root of 5 times the square root of 5. Well, we know that the square root of 5 times the square root of 5 is the square root of 25. And we know that that is 5. So then I have the square root of 5 left. Well, you just estimated this at 2.3. So then I'd really just have to say 2.3 times 5, and this would get me my answer. So I would estimate this at 11.5. This is much easier than multiplying that 3 times. So let's try another one. Let's do the square root of maybe 14. Well, we know that this is an irrational number, so I'm going to have to estimate it. So around it I have the square root of 9, the square root of 10, the square root of 11, the square root of 12, 13, 14, 15, and 16. So we know that the square root of 9 is 3, and the square root of 16 is 4. So if you remember back a couple of grades when we're going to try to find the middle here, and here would be the middle of these numbers. And so this would be 3.5. So in the middle here, if we do it again, that would be 3.25 roughly. And we could say that this would be 3.75. So I'm going to round down to that 3.6 or 3.7. So again, if I see the square root of 14, maybe to the 5th power this time. Well, if I think about it like this, it's the square root of 14 times the square root of 14 times the square root of 14 times the square root of 14. And one more. There we go. There's 5. So this squared would leave me with 14. This squared would also leave me with 14. So then on my paper, once I multiply, or if I know 14 times 14, okay, that would be 16, and then 0, and then 4, and then 1. So this is 196. So really I need to say 196 times the square root of 14. Well, we can estimate that to be about 3.7. So then I would just do 196 times 3.7 and get my answer. Okay. Now, the other thing that we can do, if we know where rational and irrational numbers fall, is that we can put things in order. So, for instance, if you had a number such as, let me see, let me give me a good example here. Let's see, 2 to the 3rd, 7.5, the square root of 70, and 2 on the square root of 10. And I wasn't allowed the use of my calculator. I can actually think about 2 to the 3rd being 8. We know that this is 7.5. The square root of 70, well again, we know this perfect squares are rounded. So the square root of 64 is 8. And then the square root of 81 is 9. So we know that this is 8 point something. It's right around there. So I'm going to leave that one for a minute. We know that the square root of 10 is really close to the square root of 9. So we're going to say that's 3.1. Well, I'm going to say 3.1 times 2, and we know that that then would be about 6.2. 6.2, 6.3, somewhere in there. So then, so this makes this 8 point something. So I save a lot of time right here if I'm asked to order these, because I know that this is going to be, you know, maybe 8.3 because it's a little bit higher than 64. It's not as close to 81, so it's not as close to 9. So then, if I'm asked to order these from least to greatest from here, then I'm going to put them in order, or greatest to least, either one. So my greatest one then would be the square root of 70, and then the next one would be 2 to the 3rd. This is greatest to least, and then 7.5, and then 2 on the square root of 10. So I'm thinking about money. So this is like $8.30, then $8, then $7.50, and then $6.20. Okay, so knowing how to estimate that takes some work out of the calculator if you're not allowed to use your calculator. All right, I hope this has helped you. Thanks.